Welcome! Today we're going to build or rebuild the game of Doodle Jump. So right here you can see the finished product. We have a little sketch here where a little red ball is bouncing off this green platform, and if I use the arrow keys I can make it move left and right. And you can now see that I'm climbing up these different platforms, and if some of the platforms disappear towards the bottom of the screen, new ones are coming in from the top, and I have a score count which tells me how many platforms I've climbed up already. And the goal of the game is, well, obviously to get as far up as possible, but if I don't play the game with the greatest level of attention and fall off the cliff here, it's going to say game over and I lost the game. I think this is going to be a fun project, and it's going to be a very good follow-up project to what we did last time. So if you haven't watched the first video of the series where we have built a little physics engine within processing in Python mode, I definitely recommend you to watch that video because I'm going to explain there what Trinket is and how you can code all of this from within your browser. And I think that's enough of an introduction. Let's get started with an empty sketch. The first thing that we will do is we'll import processing. So from processing, we will import everything, and we'll also import from the random module the uniform distribution to, well, simulate random numbers. We'll define the width and the height of our screen, and here I've decided to go for 400 as the width, and we'll set the height to 650. Let's create our setup function. So define setup. We'll set the screen size to width and height. We'll then have our draw loop, so we'll have draw function. If you don't know what setup and draw are, just go back to the previous video, watch it, and then you will understand how everything works and how processing is set up. And yeah, the first video is really an introduction to processing in Python mode. Now anyway, within the draw loop, we'll have our background color. I'm going to set the background color to, let's just make it rather dark. So we'll choose a small value. I'm just going to set it to 60. And then we have our run function. Let's run this. And there we go. We have our canvas, our background. Now we have to have the Doodler object. So I'm going to create a class, which I'm going to call the Doodler. And then we'll have our initialization function. And we'll say that there's got to be an X property, so that is where the Doodler is located. And initially, it's just going to be at width half. Now, width half could also be the very left of our Doodler object. So let's say it's a rectangle or it's a circle. It could be the left edge. And to make sure that it's really the center, what I'm going to do down here in our setup function, I'm going to set the rect mode equal to center. And this means that whenever I'm specifying one point for an object, it's going to be the center point here, okay? And now we'll have self.y, and I'll set that equal to, well, I want it to be very low, but not all the way down here. Now, all the way down here, remember the origin is in the top left, so all the way down here would be height, and I'm just going to reduce that value by a little. So I'm going to say height minus 70. We'll then specify a width. I'm going to set that to 40, and we'll have a height for our object, which I'm going to set to 40. Now I'm going to have a show function, which we'll use to display the object on our canvas here, over here. And in this function, I'm going to specify no stroke, which means we don't want to have an outline drawn around our object. We'll then have to specify a fill color, and I want this to be, well, red. And, well, I could just say 255, which is the largest possible value, that the brightest red color we could imagine. But to make it a somewhat pretty color, I'm going to choose 220 here, and also have some of the other colors present. I'm going to pick 50 for the green value and 100 for the blue value. And in conjunction, these three values should make a nice red color. And now we'll draw an ellipse at self.x and self.y with a width of self.w and self.h as its height. Now we have to create an instance of this class. So we'll call it Doodler in lowercase, and we'll make that an instance of our new class. And then in our draw function down here, which is this loop which is always happening, I'm going to first say draw background and now show Doodler, and then we'll say doodler.show. And that's really all that we will need. Let's run this, and there we go. We have created our Doodler object and we have drawn it onto the screen. Next thing that we'll need are the different platforms, or, well, you know what? Let's first have it move up and down, and we'll start with the downward movement. Now, to make the Doodler object move, what we'll do is we'll say that there is a change in dy, which is, well, are we going up or are we going down? And if dy is positive, then we're going down. And at first we'll set that equal to 0. And now we'll have a move function, so def move, a function of self, where we'll say that the first thing that's happening, there will be more, but right now the first thing that's happening, we have gravity. So self.dy is plus equal 1, and then we'll have another part here, another code chunk, which will be the actual movement. So here I'm going to say self.y plus equal self.dy. So to our current y location, we are adding the change in the y location, which we set to 1, which is gravity, so it's being pulled down. And then we'll say self.x plus equal self.dx, which is the change in the x direction. I have not declared that up here, so let's do that up here. And yeah, that's really all we need right now. Let's see if that works. Let's run this. It's not happening because I'm not making use of the function down here in the actual loop of the game. So what I'll have to do here in our draw loop before we are showing the Doodler, we'll say, well, we have the Doodler movement, and we'll say doodler.move. So let's run this, and there we go. You can see it's falling off. Now to make this more visible, let's just set this to 0 and run this again. And now you can see the Doodler is coming in from the top. It's falling down, and well, that's really all there is to gravity. So let's reset that to height -70 so that it starts out somewhere down here. And now it's time to add the platforms. Now the platforms, we can just copy most of what we have up here and create a platform class. So platform. The initialization, we'll want to make sure that we can specify where this platform is so we can place them strategically onto our canvas here. So I'm using x and y here as two variables within our initialization function. And then we'll set the x of the self, that is the platform, equal to x, and we'll do the same thing for y. Now the width of the platform class, I'm going to set this to 100 and the height to 20. So they're going to be very narrow, but they're going to be quite wide. And then dx and dy, I don't think we'll need these for the platform class. The show, well here, I'm just going to swap the red and the green value. So we'll have a very large number as the green value and a small number for red, which should make them green. And now instead of an ellipse, we'll draw a rectangle. Other than that, the show function will be basically the same thing. We will not need the move function for now. We're perfectly satisfied with that. And let's create a platform. So platform is equal to platform. And you know what? Let's right away make this a list of different platforms, even though that list for now is only going to contain a single platform. And that first platform, well, we'll put it in the center, so width half, and then we'll say height -50, which should place, or like -30, which should place it just almost all the way to the bottom here, but underneath our Doodler. So down here it says show Doodler, and then we'll say show platforms, and then we'll say for every platform in our list of platforms, even though it's just one value, well, not one value, but one platform object. So for every platform in platforms, we'll say platform.show. Now let's run this, and there we go, we have our platform. It doesn't look too pretty, that's because it has these perfect 90-degree angles. And to sort of smoothen that a little bit, to make them sort of round, we can introduce another parameter up here in the rectangle function, and this will then make them somewhat round. And I think if we choose 0 here, in that case, they will be perfect 90-degree angles. If you make this something small, like 5, there's going to be some, it's not going to be like a little bit round, but let's make it 20, and I think this is going to be just fine. Okay, we have the platform, we have our Doodler object, so now it's time to have the Doodler jump off the platform. And the first thing that we need is, well, we gotta figure out whether or not the Doodler has actually landed on the platform. So we gotta have some kind of function to check whether or not a Doodler has landed on a given platform. And what we'll do is we'll have this function within the Doodler class. So I'm in the class here, and I'm gonna just call it lands. So this function is going to take a self and some platform p. And now this function will return whether or not, so we are landing on that platform. So it returns false if we are not landing on this platform. But if a certain set of conditions are met, then we'll return true from that function. The first thing that we got to make sure is within this lands function is that we are actually moving downwards. Now, it's just a feature of the game that when the Doodler object is moving upwards, it goes straight through any platforms that are within its way. But when we're coming back down, then we can bounce off a platform if it's in our way. So the first check here is if self.dy is greater than 0. Now, only if that is the case will we return true, but there is more to that than just moving downwards. Now, the next thing that we got to make sure is, well, we have to be like on top of the platform in terms of not being too far to the left and too far to the right. So what we'll do here is we'll say if self.x, so the center of our ball, plus, and now, well, in theory, we should go all the way to width half, which is then half of its width, half of its diameter. But what I am going to do is I'm just going to set that to width and a quarter of that width. And what that is going to do is it's going to say, well, it's not enough if the ball just about scratches the edge of the platform. It's got to be on there a little bit. So there's got to be a sizable portion of the ball on top of that platform. Otherwise, it's really just going to roll off there, but not bounce back. So this is why I'm using width quarter here instead of width half. Now that has got to be greater or equal to p.x. So that is the center of our platform. And then from that, we subtract width half. So minus p.width half. So just to make sure what we're doing here, we are checking a collision between our ball, and we are checking whether it's right-hand side edge, but not really the edge, but just like half of the edge, so to speak. So that's the idea of this width quarter here instead of width half. If that is greater or equal to the left-hand side, the left edge of the platform. And now we're just doing the same thing for the right-hand side as well, because otherwise the ball could be over here falling down, and we're just checking, hey, we are to the right of that, perfectly fine, but we also want to be to the left of the right-hand side edge. So what we'll do is I'm just going to copy this, replace this with a minus sign, replace this with a plus, and make this less or equal to, and that should really be it. Now lastly, we checked the, we just checked the horizontal dimension, but now we also got to check the vertical dimension. And here, I'm just going to say if self.y plus and now I'm going to use height instead of width, but now I'm also really using half, because now I'm really checking whether the bottom of the bottom edge of our ball. So we're not like checking whether we have intersected with our platform here. We're just checking whether we are really landing right on top of it in a given point in time. So if that is greater or equal to, I can just copy this again, replace x with y and w with h. And then let's just take all of this, make this y, this h, this half, and again y and h. Now if all of these things are the case, then we are returning true, and otherwise we are returning false. Okay, now we can go down to the Doodler movement, and before we are actually moving our Doodler, we'll just loop through all of the platforms. So for platform in all of the platforms, we are looping through there, and we are checking if our Doodler lands on that platform that we are currently looping over. And if that is the case, we want our Doodler to jump. We'll implement that in a second, and then we'll just break out of that loop because we have found, one platform to land on. We are moving up, next frame of the animation, and then we'll run that check over again. Anyway, the jump function, I'm gonna have this like underneath the land function here. So I'm just going to say jump. It's going to be a function of self. We are still within the Doodler class, and all that's happening here is I'm saying that dy is set to -20. So there's a strong upward movement going on. Now let's see if that works. We have our platform, we have the Doodler, and there we go. So we can now see it's bouncing up and down on this little platform here. Wonderful. The next thing is to add, well, movement to this ball here. So right now we can't move it. I can press the arrow keys as much as I want. We're not moving back and forth here. So down here, I'm going to have this run in the background. And down here, we'll now have two more functions. In the last video, you learned about the function called mouse pressed. So this was something that happened every time that we pressed the mouse. Now we are interested in key presses. We want to have the user use the left arrow key to move the Doodler to the left and the right arrow key to move it to the right hand side. So what we'll do is we'll say if key, define key press. This is completely analogous to the mouse pressed function. Just need more spaces down here so I can scroll down a little. And then we can just say if the key code, this is how we can access distinct keys, different keys in processing. If that is equal to, and then we'll just say left, then, and what's also important here, now if we are moving to the left and we are holding that key down for a little while, we don't want this ball to speed up further and further. So there's got to be some kind of maximum speed, otherwise it's just going to move over a little and then accelerate and just move off super quickly, and we don't want that. So what we'll do is we'll say, and if the Doodler change in the x direction, if that is greater than -5, only then are we going to, so if you're like, at -10 or something, we don't want the dx, which if you're moving left is negative, to decrease further and further. So we're checking that we got to be greater than -5. And if that is the case, then we'll say doodler.dx minus equal 3. We're then decreasing it. And now we can use that same logic for the right hand side. So that is equal to right. And now here we're checking whether we are less or, well, we could also make this greater or equal, less than equal, doesn't matter, less than 5. In that case, we are increasing the dx by 3. Now, if we are implementing key pressed, we also got to make sure to implement the release. So here, if the key code is equal to left, we don't have to care about this anymore, then dx is equal to 0. And now the same thing with releasing the right hand side arrow key, the right arrow key, we'll also set that to 0. So let's see if that works. So ball's bouncing, and now I'm pressing the left arrow key, and it's unfortunately not working because I must have missed a little something here. It's probably in the move function. Let's go up here. No, I do have movement implemented up here. Dx dy. So what's the issue here? Yes, simple mistake. I just copy pasted the key pressed and did not change it to key released. And now I can move the ball over. You just saw that, how I'm moving it one step at a time. But I can just keep one of the arrow keys pressed down, and then we have a smooth animation of us moving to the right and then going off limits here. Now, one of the features of Doodle Jump is that if we go off to the right-hand side of the screen, we're coming back in on the left. So let's quickly introduce that before introducing the additional platforms here. So in our movement here, we'll now add this going out of bounds idea. So going out of bounds, this is going to be very simple. If self.x is greater than the width, then we'll say self.x is equal to 0, and elif self.x is less than 0, self.x is equal to width. Now let's see if that works. Ball's bouncing, I'm moving it to the right, and you just barely saw it coming in from the other side. Let's try this again. Move it like all the way over here and then go out of bounds. It doesn't really make a difference, but I think you saw the idea that we can now go off to either side and we come in from the other. Okay, let's add some more platforms to this. And this is now happening in the platform list. So add a bunch of these platforms. and I played around with these values, and I found that just having them spaced somewhat equally just ensures that there's always one platform that you can jump on next and just, keep on climbing up. So what I said is I'm just going to divide this by 5, height divided by 5, and then height divided by 5 times 2, 1/5 times 3, so 3/5, and then another one at 4/5, and that's really all we need here. So right now they're just stacked on top of another, so that's going to be very boring. So you can just see us sort of climbing up this ladder here. So let's not all just put them at like the same x value, otherwise we would have this ladder effect. And what I did here is I said the first one is going to be, it doesn't really matter where you put these, but just make sure that you can get started with the game, and then they're coming down randomly anyway in terms of being left or right. But just choose some values here where the user can jump up some initial couple of steps. It could also be this perfect ladder here, but what I did was I said, okay, this is going to be at 2/3 of the width, and then we'll have one sitting at the quarter, like 1/4 width, and then 1/3, and then lastly we'll have 3/4. And if we do it like that, you can see that we can now jump up the initial stages of the game. We could also fall back down, but it sort of looks realistic, and we don't start off with a perfectly formed ladder. Anyway, the next step would be for us to, well, I mean, this is nice, but once we reach the top, we want the game to sort of move down. We want the platforms to move down and then disappear, and then new ones coming in at the top. So where do we do that? Well, we have the Doodler movement, which is what we can see happening over here right now. And now what we want to do is we'll have the platforms move as well. So we'll have platform movement happening over here. And when do the platforms move? Now the platforms only move if we are in the top half of the screen. So if let's just go over here. If I'm down there, I don't want the platforms to move down. Otherwise, this would be way too hard. But if we are over here, let's say up here, then we want the platforms to start moving down. So the first thing that we will check is platform movement. We'll say if doodler.dy, just y, the y location, if that is less than width half, and doodler.dy, and this is now also important, if that is less than 0. Now what does doodler dy less than 0 mean? So the change in the y direction is less than 0. So remember that the origin is up here, so dy is less than 0 means we are moving up. I mean, you don't have to code it like this. You could leave out this part, but this would mean that you may be falling down, but the game is then still moving up. And this might be very hard in certain situations. And I think it's just nicer for the player if you're only like making the game harder if we just, successfully jumped or bounced off one of the platforms. And this is why I have this second statement here. Now, if that is the case, then we'll start looping throughout all of our platforms. So I'm just going to copy this from down here. Copy, paste this in here, indent this properly. Now we'll say the platform.y minus equal whatever our current doodler speed is. So we have minus minus, which is plus, so the platforms start moving down. This is exactly what we want. And then we'll say, well, let's just see what that looks like. So we start climbing up, and now you can see how they're moving down. Only problem being, if we're up here, well, there's no new platforms coming in from the top. So we have them disappear towards the bottom, but now we want new ones coming in from the top. And what we'll now do is we'll say if a platform, if its y location, if that is now greater than height, it's gone off limits. We can't see it anymore. Now we can just reset that. So what we'll do is we'll say platform.y is equal to, and now we'll use the uniform distribution. And I'm just going to take the difference between where it is right now and height, which is sort of the last bit where we would have seen it, the last pixel where we would have seen it. And we got to take the negative of that and 0. And now it's then going to be coming in from the top. And this is going to be platform, not plat4. And then we'll also specify a new x location, platform.x, again, random distribution between 0 and width. And yeah, that's all there is to it. So let's see if that works. And now, there we go. So we can now see the Doodler is, sometimes the game is sort of playing itself. If you get lucky, you're jumping up and then a new platform is coming in from the top right where you're currently falling down. And this is then really helping you, and the game is sort of getting very easy at that point. But at some point, you won't get lucky anymore, like here. And now you gotta, carefully navigate towards the next platform. And yes, so the next thing would be for us to have a score count up here, and then if we fall off here, we want to have a game over statement. Now the score count is going to be, both of these things are very simple. We'll go into the Doodler class and introduce a score, which we'll set to 0. And now in our draw function, in our draw loop, we have first the background, then the Doodler movement, platform movement, then we show the Doodler and we show the platforms, and now we'll show the score. Now, drawing text to the screen, if you're using something like Pygame, is always a bit of a pain. You have to initialize fonts, you have to create a font, you then have to create a text and, blit that into a, object like a rectangle, and then you have to blit that onto the screen. There's like multiple lines of code just to do that one thing, and you must not forget about converting an integer or a floating point value to a string, otherwise you won't be able to display that, and all of that is completely gone in processing. In processing, that's super simple. Now in processing, all we have to do is, we have to simply say text. We'll take the Doodler score, doodler.score, and then we have to say where do we want this to be drawn. I want this to be in the top left corner, so we'll indent this maybe 10 pixels to the right, and then we'll have it maybe 50 from the top. And then similarly to the other drawing functions here, we have to specify a color. So let's just have the fill, and I'm just gonna pick a very bright value here because we have this dark background, and then we have to specify a size, and we do that using the text size function. I'm going to set that to 50, and let's see if that works. So we have our 0 up here, but right now the 0 is not increasing even though we are moving up. So let's make sure that our score count, our score is being kept. So every time that a platform moves, not every time it moves, but every time it goes off limits, goes down here and respawns at the top. In that case, we want the doodler.score to increase by 1. So let's stop this and run this again, and let's see if that works. So first platform, 3, 4, 5. As I said, the game sometimes it feels like it's playing itself, but now we are at a score of 7, and let's move over here. 8, 9, and yeah, you can now really see how this is working. Let's go over here and then go back here. And yep, we have now created our game. And I think really the last thing that I'll be implementing in this video will be the game over message. There's lots of things that you could do, but let's just implement this game over message. So when I go off here, fall down, I want there to be a little message. And show score, and here we'll say show game over message. Now, when do we need that message to appear? Every time if the Doodler y location, and then maybe minus doodler.height half, so that's the top of the Doodler, the top of the ball. If that is greater than the screen height, then we've gone off limits and we will never come back from that. Then we'll say fill is equal to 220, same thing as what we have up here. Let's take that, copy it, but instead of the Doodler score, you don't have to use fill and text size here again, but I just feel like we should do that just to be extra safe. So if there's something drawn in between these two that changes the fill, the color, then the game over message would have a different color, and this way you can really make sure that it's always the color that you want it to be. Now anyway, I played around with these values. Now first, let's make this game over. Game over. And I figured that if you use 50 here and height half, now if you've chosen a different screen height, not height, but different screen width, you might have to play around with that 50. But for me, this now puts the game over message right in the middle of the screen. So let's intentionally lose the game. And now it says game over. Okay, so this is really all what we'll do in this video. We have successfully recreated the Doodle Jump game. And now there are a bunch of things that you could do to make it even better. I mean, you could, instead of having a just a circle, you could have a little image that moves around. So you could import into processing here an image like the original Doodler image. So you would import like a PNG file or a JPEG. And then instead of, drawing this little red circle, this ball here, you would then draw the image file. And what else could you do? You would then have maybe two images. So if you're going to the left, it faces one way, and if you go to the right, it faces the other. You could have some kind of background, and this could be something you could easily implement on your own. You would have maybe some clouds in the background, so make the background color blue, and then have, sort of similar to the platforms, create another class which you'll just call cloud. And a cloud, it has an X and a Y, similar to the platforms, but then don't just draw one rectangle, but draw multiple ellipses which are sort of overlapping, make them white, and this should then form a cloud. And then you have these clouds, moving similarly to the platforms, but the only difference being you cannot land on a cloud, so they'll just always be in the background. And then this will feel, I think, even better, and you will have, sort of a more realistic animation, even though, I mean, what's this supposed to be anyway? But it will feel a lot more like the actual Doodle Jump game. But I think this is now enough for this video. I hope you enjoyed the video, and I hope to see you in another video. I'll continue this processing series because I think it's probably one of the best ways for beginner Python programmers to get into Python. You can run everything in your browser, and it's going to be super fun. And yeah, see you in another video.